Good day, everyone. This lesson is going to be about factoring trinomials. Remember, three terms that do not have a leading coefficient. And we're going to warm up first by doing some reminders about the product of two binomials, and then we'll go backwards to do factoring. So you should have a page that looks like this. I love this page just as some practice. And you might remember that we could distribute. I'm going to walk through one of these at the bottom. We can just distribute as usual, but you'll notice that all of these have a common term. The first term in both binomials is simply x. It wouldn't matter if it was k or g or c for Carolyn, but there is a common term at the beginning. So if I distribute, remember we would do x times x, x squared, x times 4, 4x. You might also call this FOIL, first times first, outside outside, inside inside with the 5 times x, and then last times last, 5 times 4. And then we would have the step where we should combine the middle terms, so that we would be left with x squared plus 9x plus 20. And there is nothing inherently wrong with doing that. It's beautiful, it's functional, it works, but we're going to start going backwards from that trinomial, x squared plus 9x plus 20, and get back to those two sets of parentheses. And so to do that, we want to notice some things that happen, and it's kind of pointed out at the top of the page too. Let's do one more the long way and then make some observations. I have x squared, I have 3x, 1x, or simply x. I'm going to write 1x for the moment. And then 1 times 3 is 3. And then the 2 in the middle would add together. And that would be our final answer. Well, we're going to go straight to that answer. Okay, I'm going to show you how to do that. So you may start to notice, they both have x squared, because x times x is, of course, x squared. If I just look at these two, these are just going to be constants at the end, the second term. If I look at these constants, and I add positive 4 and positive 5, notice I get the middle term. Now that's always going to have an x with it because it really is getting multiplied times those x terms and then getting added together. So the middle, we're going to add to get the middle, and then 5 times 4 is 20. We're going to multiply to get the end. So their product is the last number. So now let's try it with the shortcut. So x times x, x squared, 7 plus 2, 9x, 7 times 2, 14. Pretty tricky, huh? So let's keep going. X times x, x squared, 1 plus 10, 11x, 1 times 10 is 10. Now, so far they've all been positive. When they are negative, we need to think of that minus in the middle being stuck to the constant, being part of the constant. So I'm going to still get x squared, but I'm going to think of this as positive 4 and negative 1. So when I add positive 4 and negative 1, I get positive 3, gets an x always in the middle, and then 4 times negative 1, negative 4. Some of you may have picked up on this kind of shortcut before, but because we didn't do very many problems that only had x at the front, you may not have had a chance to pick up on that shortcut unless you've done this previously. So x squared, 8 and negative 2 makes positive 6x. 8 times negative 2, negative 16. X squared, this time we have negative 7 and positive 2. So the negative is bigger. So notice how when they're different, the number parts are subtracting to give the middle, but the sign matches the one that's bigger. And this is still negative 14. Every time we get a negative out here at the end, my two signs had to be different because that's the product at the end. And for the product to be negative, the signs would have to be different. That looks a little distracting, so I'm going to take it back off. All right, so for number 8, now I have negative 5, x minus 5, x minus 1. So x squared, when I add negative 5 and negative 1, I get negative 6x. And when I multiply negative 5 and negative 1, I get positive 5. Okay. X squared, this would be negative 9x and positive 20. So when that last term is positive, the signs were the same, right? Because to multiply and get a positive, you'd have to have the same signs. And then if the middle is negative, oh, they were both negative. All right, so try the second column or go back and try some of these. Make sure you get that same answer. We're going to turn it over to go in the opposite direction, thinking about some of the patterns that we noticed about the signs. It's going to be really important when we're going the opposite direction. We're going to think about the signs, and we're going to think about first the factors of the constant, the last number. All right, here we go. I do not need to save those changes. Suddenly I'm making sure that so now we're going to factor, and you'll see here they show you all these possibilities. This is what your colored sheet gives you, the different factor pairs. They know because it's negative 15 that the signs would have to be different. So it could be 5 and negative 3, or negative 5 and positive 3, or negative 1 and 15, or 1 and negative 15. All of those would give you negative 15 at the end, but only one of them also adds to the 2 in the middle. We don't want to try all the things that add to 2 because we would have infinite possibilities. We try the things that multiply to be the constant. So we're looking for factors of 15 that add up to 8. And my answers are going to look like our problems on the other side of the page. So I like to just go ahead and write my two sets of parentheses. I know to get x squared, I must have x and x. And then this is a positive 15, so the signs have to be the same. So this tells me same signs. And then I'm going to look back and see, oh, they're same, and they must both be positive. So then what numbers multiply to be 15 and add up to be 8? Well, our choices are 1 and 15 or 3 and 5. By the way, it doesn't matter which order. If you put 5 in the first parenthesis, 3 in the second, doesn't matter. If the signs are different, it matters who goes with which sign. So so x and x, again, both are positive because I know, not because I see two pluses, but this means they have to be the same. And if they add up to a positive and they're the same, they're both positive. What multiplies to be 2? Yeah, we have one choice, 2 and 1, or 1 and 2. The order, again, is not important. Go ahead and try number 3. Pause me, see what you get. What two numbers multiply to be 10 and add to 7? 5 and 2. These numbers are purposely kept small. Sometimes you're going to see bigger numbers. That's where your sheet is going to help. And that's where if you didn't memorize your multiplication facts, it's going to be a little bit slower for you. Not that you can't still do it, but it's going to take you a little longer. All right, we get our first challenge on number 4. In number 4, as soon as I see that this is negative 12, I know the signs have to be different. I still have x and x, but I know the signs have to be different. So since they're different, the two numbers really subtract instead of add when I just think about the number part. So I'm thinking what multiplies to be 12, and sometimes we'll make this little x, it's just a little organizer. What would multiply to be negative 12, but adds up to be 4? Well, the signs would have to be 1 plus and 1 minus. So 1 and 12, but if I subtract those, that's 11. No. 2 and 6, if I subtract 2 and 6, I do get 4. And then it's important, I want the 6 to be with the plus because I need to get a positive 4 when I combine those. So the bigger sign in your factor has to match the middle. So here on number 5, same kind of problem. X and x, different signs. What multiplies to be 8, but they're different signs, so they really subtract to give me 2. Yeah, 2 and 4, and I need to get a positive 2, so the 4 is the bigger number, it needs to go with the positive. So number 6, x and x, and then think about what we know about their signs. If you put in two negatives, please erase one of them or change it to a plus. This is still negative, which means the signs must be different. And you can write the minus first if you want, but the signs must be different because the last term is negative. So then what multiplies to 12 adds up, so multiplies to negative 12, adds up to negative 4. Again, one is plus, one is minus. They're going to subtract since they have different signs, so it is still 6 and 2, but this time 2 is with the plus and 6 is with the minus, so that we get negative 4. So it looks very similar to number 4, except the signs are switched. Any of these you can always check by multiplying it out, or if you picked up on the shortcut of the other side of this page, try that shortcut. Make sure that they add together to get the middle and multiply to get the end. People would catch most of their mistakes if they just paused and thought about that. Alright, so again, last term is negative, the constant's negative, it's going to be one of each sign. What multiplies to 10 but adds up to 9, or in this case subtracts since they're different? You might be thinking, I can't think of anything except 2 and 5. Don't forget 10 and 1. Yes, 10 and 1, and if I put the 1 with the plus, the 10 with the minus. Very good. And then this last one we switch back. This time, now we have a plus with our constant. That tells me, remember, that the signs are the same, but don't get lazy. We need to look back here. Oh, they're the same, but they add up to a negative, so they must both be negative. And then they really do add. So what two numbers multiply to 12 and add to be 7? Yeah, 3 and 4. And you might think negative 3, negative 4, or if you've already settled the signs, then you're just placing your 3 and 4 at that point. Okay, so that's what's happening in this lesson. And go on to our other page. All right, so this is very much what we already practiced. We just had a longer warm-up because I find that that is helpful. So if I would multiply these out, again, we get x squared, 5x plus 5. And we know the shortcut now that we could just add 5 and 1 to get 6 in the middle. and 5 at the end. Doesn't matter, it could be an m instead, so m squared plus 6m minus 4m minus 24. And then notice when they're different signs, those two middle terms, when we combine them, subtract. And then this last one, k squared minus 3k minus 7k plus 21. And then the middle, again, combines. Two negatives add up to be a bigger negative. Those trinomials on the right can be factored back to what our original questions were, which is just what we just practiced. As you're factoring, you need to, if you think about this being x squared plus bx plus c, where b and c are numbers, they're integers, then we need to find two integers that multiply to c and add to b. And that's what we just practiced on our other page. But you want to think about that they multiply to c first. So think of what two, they have a product. Remember, product is multiply, sum is add. So what integers have a product of 12 and a sum of 7 would be 3 and 4. And then we write the two binomials, x plus 3, x plus 4, and always you can distribute to check. That should be a very familiar statement because we have used that idea throughout factoring. So as we go down the page, you'll see these are very much like what we've just done. Remember that things can multiply to be 1. We can have 1 times 1. So in set 1, these are both going to be positive. So in both of them, we're going to see positives because the signs are the same and they add up to a positive. In set 2, this is going to be, these are all going to be one positive, one negative, because the signs are different, because C is negative, but B is positive in all these. So when C is negative, the constant is negative, but the middle is positive, then you're going to have one of each, but this one has to be bigger. I'm not sure what I was getting ready to write, but bigger. If C and B are positive, then they're both positive. When I talk about B and C, B is the middle, C is the end. A is really the coefficient of the squared term, but in this case it's always 1. And then in set 3, you'll see again that C is negative, which tells me different signs, but B is also negative. Tells me the bigger is negative. So then I know I'm going to have a plus and a minus, but this one is going to be bigger. And then in set 4, we see that C is positive, And I list C first because that's really what we should look at first. I never memorized the patterns myself. I just thought this is positive, the signs have to be the same. But if they're the same and they add up to a negative, they must both be negative. So then they would be two negatives in the middle. And again, we practiced some like all these previously. So here, A, 1 plus, 1 minus would be 3 times 1. 1 would be with the plus, 3 with the minus, so that we get negative 2. So on 13, what multiplies to be positive 24, so signs are the same, but it adds up to negative 11. So 2 negatives. All right, 1 and 24, no. 2 and 12, no. 3 and 8, ah, ding, ding, ding. And maybe that just came to you immediately. If it doesn't, look at your factor sheet or be systematic, or you might just jump over the one you're looking for. And then in the next section, they are mixed up, all right? They're mixed up. And so you have to pay attention. I know that's hard, right? You have to pay attention. This is mixed practice. And then this last part, I'll give you some examples here. We did not do this on the other sheet. Notice it says look for a GCF first, then factor. So 4 goes into all of these. So 4 goes to the outside. Then I have k squared plus 12k plus 8. That 4 stays part of your answer on the outside. Then this trinomial will factor into 2 parts. So what multiplies to positive 8 and adds up to positive 12, so they're both positive. That is not even, rewind me, sorry. I did not divide these other two. It's like nothing does. So that's where you can find your mistake. If you're not finding anything, perhaps you made a mistake. How about let's go with 3k in the middle and plus 2. And nope, I won't be redoing this whole video because I waited and made a mistake this far in. So now, thank you for your grace. What multiplies to be 2 and adds up to be 3, a2 and a1. So at this point, if you see something at the beginning, a coefficient at the beginning, that's probably going to be at least part of your common factor, because we don't know how to deal with it otherwise, okay? Unless it was perfect squares and only 2 terms. So let's look at 26. So they all have an 3, and remember they all have an a. So go ahead and take out everything you can on a GCF. So now I have a squared plus 10a plus 21. 3a is still part of my factors. Then my trinomial is going to split into 2 binomials. What multiplies to 21 adds up to 10. Both are positive. 3 and 7, or 7 and 3. Right, so take out your common factor. You guys have gotten really good at doing GCF. Then factor what's left. All right, and remember the common factor is part of your final answer. It only appears outside of one of the parentheses. And then you have a homework page. All right, best of luck. You don't need luck.